At long last, we've reached the fourth and final unit of Math 151, and we're into our final chapter, which is Chapter 9. This is Section 9.2, which deals with exponential functions. Now, one of the main focuses of this course, Intermediate Algebra, is just to introduce you to a bunch of different kinds of functions, right? So we've dealt with linear functions, rational functions, radical functions, quadratic functions, polynomial functions in general. And now we're getting into a new type of function called exponential functions. So this first box here, what it does is it just gives you some key phrases which would help you identify that a function is going to be exponential. Alright? So if you see a phrase such as the account was earning 4% interest per year, right? Because the key there is 4% interest per year. The number of bacteria in the test tube was doubling every 5 minutes. So the key phrase there is doubling every 5 minutes. The amount of radioactive material is decreasing by 5.5% each year. So you should kind of see like a common thread to all those. They all really involve percentages of increase or percentages of decrease. Now you might say, well, the second one talks about doubling, but really doubling is really a percent increase. When you say something's doubling, that means it's actually increasing by 100%. Okay? So if something's doubling every 5 minutes, it means it's increasing by 100% every 5 minutes. So bottom line is, generally when you see percentage increases or decreases, that's going to be a hint that you're dealing with an exponential function. Okay? So the above are all examples of situations that could be modeled with exponential functions. Alright? So we're going to look at 4 tables here, 4 tables of values. And we're going to decide what kind of function they represent. Okay, so the first one here in blue, we have x values ranging from -2 to 2 in increments of 1, and y goes from -4 to 0 to 4 to 8 to 12. Now, what we're going to do here is first we're going to call these y values. What these are is, we'll call them successive outputs, right? Because remember, you can always refer to the x value as the input and the y value as the output. So these numbers here, the -4, 0, 4, 8, and 12, we can refer to them as successive outputs. And what we want to do is we want to see how they're changing. Okay? So how are the y values, right, the successive outputs, changing? So they go from -4 to 0, then from 0 to 4, from 4 to 8, and from 8 to 12. Now in each of these cases, you can see that to get from one output to the next output, you actually had to add 4. Okay? So in the first table, to get successive outputs, you would add 4. Alright? Now in the second table, which deals with the same inputs, right, from -2 to 2, now we have successive outputs that are going from 0.5, which is a half, right, think of this as a half, to 2, to 8, to 32, to 128. So it's clear in this case that the successive outputs are not just changing by a constant number, right? From a half to 2, like let's say you were thinking you were adding here. If you're going from a half to 2, you're actually adding 1.5. But then to go from 2 to 8, you're adding 6, and then to go to 8, from 8 to 32, you're actually adding 24. So you're clearly not adding the same value to get your successive outputs here. But what you're actually doing, if you think about it, is you're actually multiplying by 4, right? A half times 4 will give you 2. Then 2 times 4 would give you 8. Then 8 times 4 would give you 32. Then 32 times 4 would give you 128. Right? So in this case, you actually have a constant factor that you're multiplying by, right? Whereas in the first case, you actually have a constant difference, right? Because you were adding. So what's the difference between 0 and negative 4? 4. What's the difference between 4 and 0? 4. Difference between 8 and 4 is 4. Difference between 12 and 8 is 4. But over here, the difference isn't the same, it's a factor, right? To get from a half to 2, you multiply by a factor of 4. To get from 2 to 8, you multiply by a factor of 4. 8 to 32, you multiply by a factor of 4. So on and so forth. So what we've just illustrated here in these first two tables is the difference between linear growth, right, where you're adding a certain value to get from one output to the next, and the second one is actually exponential growth, because instead of adding to get from one output to the next, we're actually multiplying. Okay, so right there in a nutshell, that's the difference between linear and exponential growth. In linear, you're adding to get from one output to the next. With exponential, you're multiplying to get from one output to the next. Okay, and I mean, at least with the linear one, you pretty much know what the equation is, right? Because remember, the general form for the linear function was just y equals mx plus b, right? And m was the slope. And if you remember, when you first learned about slope, what you did is you referred to slope as the rate of change. And in this case, what's the rate of change? The 4. So in this case, the slope is going to be 4. And of course, the b was the y-intercept, right? And the y-intercept was just always the value of y when x is 0. And when x is 0, in this case, y is 4. So you know here that b was 4. So the equation of that first table would actually be y equals 4x plus 4. Alright. Now the exponential is a little bit different, and we will get into that in our next video. But right there, that was the difference in a nutshell between linear and exponential growth. Okay? And then, as you could probably predict, the following two tables, right, the third and fourth table, are going to give you the difference between the linear and exponential decay, we'll call it, right? Instead of growth, we can call this decay because it's decreasing. So in this blue table here, now our x values are different. They start at 0 and go to 4, but we still have the successive outputs here then, right? Because we're going from 0 by 1s to 4. So in this case, our successive outputs are going from 20 to 18 to 16 to 14 to 12. So again, you can see here that you are actually subtracting 2 to get from one successive output to the next. Right? And then in the bottom table, same inputs from 0 to 4, but now the outputs 40 to 20, 20 to 10, 10 to 5, 5 to 2.5. So in this case, you'll say, well, I'm not multiplying, I'm actually dividing, right? 40 divided by 2 is 20, 20 divided by 2 is 10, 10 divided by 2 is 5, 5 divided by 2 is 2.5. But again, remember, division is really the same as multiplication by reciprocal. So rather than think of this as dividing by 2, we can actually think of this as multiplication by a half. So again here, we still have a constant factor, which is a half. And in the previous one, we had a constant difference, which was -2. It's the same scenario, except now here the functions are decreasing rather than increasing. So our third table here, the blue one, is going to be linear, where the slope is going to be -2, and the y-intercept in this case is going to be 20. So this is going to be I'll call it linear decay, even though I usually don't use that phrase. Usually we just call it linear decreasing, but we're going to use decay for exponential, so I'll just call it linear decay. And again, in this case, it's still a y equals mx plus b equation, and now here the slope was -2, so this is -2x, and the y-intercept was 20, right? Because b was the 20, and m was -2, right? So that was linear decay, and then of course then our final table in red, oops, it's not linear. There we had a constant factor again, so that was exponential decay. Okay, so the main thing to get out of this first video is just the idea that when we're going from one output to the next, right, if we have a linear function, we're either going to be adding or subtracting. Okay, so in our first table we were actually adding 4, right, to get from one output to the next. In our third table we were actually subtracting 2 to get from one output to the next. So that was linear growth and linear decay. And then with exponential growth and exponential decay, we're actually multiplying, we're actually multiplying by a constant factor. So in our second table there, right, the first red one, we were multiplying by 4, so that was an exponential growth. And then in our fourth table, that second red one, we were multiplying by a half there, and that was exponential decay.